Hello friends, today we will discuss about delegates. So what is delegates in C#? Here are the topics which we will cover today. What are delegates in C#? What are the types of delegates and practical examples of our delegates? So we will cover all these delegates in today's session along with examples. So let's begin. So our first topic is a delegate. So what is a delegate? A delegate in C# is a type safe reference to a method. Type safe reference means we pass the method reference to the delegate. If we want to use that delegate with the method, then only we pass the reference, not directly we call the method with the parentheses. So it is a main functionality of delegate. We pass reference of method to the delegate, and after that we invoke that delegate with that method reference name where we want it. It stores the address of one or more methods with a specific signature, parameters, types and return types. So in delegate we can store multiple methods reference only, not directly we call the methods, and it stores the method reference. Along with that it also invoke that methods in a sequence, not without any sequence. It also follows a specific signature in a delegate. If we want to use our methods with delegate, then we have the same parameters with the same return types as we have in the delegate. There we provide the delegate definition and where we have the method. So these signatures should be matched if we want to use the delegate. Third one is delegates are derived from system.delegate and are mainly used for callbacks, events and passing methods as parameters. So if we want to use the delegate, we have this namespace system.delegate. If we do not provide this namespace, we can easily use the delegates. It is not compulsory that we have to mention that. If we want to declare the delegate, it automatically get that this one is the delegate definition, and it is mainly used for callbacks. Callbacks means if we do not like invoke all the methods at once, means where only we need that method, only there we can call that particular methods, and we provide the reference of the method to the delegate, and suppose we have 3 methods and not all we have to invoke all in a sequence, then we have to put all the reference of the methods into a delegate, and then we can call it one by one through any methods we can call. So, and we also pass the methods as parameters while using the delegates. Here are some types of delegates like single cast delegate, multicast delegate, generic delegate. Generic delegate also have 3 types. First one is Func, action and predicate. Next is delegate with anonymous method, means without creating any name we can create directly the method with the delegate. Delegate with Lambda Expression. So these are the delegates we will cover further with one by one with example. First delegate we have single cast delegate, a delegate that stores only one method reference at a time. Means if we want to go with the single cast delegate, then we only provide the one method reference, not multiple method reference at a particular time. Okay, so only we can use the single cast delegate. If you want to assign a new method, it overrides the previous one. If we want to assign a new method with the delegate while using the single cast, then it overrides the old method reference. So why use it? When you want to call exactly one method indirectly, for example in a callback scenario, as I already told you, if we have only one method and we want to invoke only one method through the delegate, then only we can go with the single cast delegate. And we have example like callback scenarios. If we have 2-3 methods and we want to call that particular method on some particular time, then we can go with this. Means we do not directly call that methods through the delegate. First we pass the reference of the method to the delegate, then only where we need it that method to call, then only we can call it through the delegate. Here are some key points. Its signature of method must match the delegate signature. So it is must if we want to use the single cast delegate, so its signatures should be matched, means the method signature and the delegate signature. First we have to initialize, means put the delegate definition where we have return type plus parameters, that should be matched with the method signature. Method signature means return type plus parameters. So this is a must, that we have to match the signatures of the delegate. Single cast delegates are most commonly used in point-to-point communication between methods. Single cast delegate means point-to-point communications. Mainly thing is that if we have only one method and we want to invoke that particular method through the delegates, through the single cast delegate, means only one sender and one receiver, example here we have, and then only it is a kind of point-to-point communication between one method and one delegate. So that is a single cast delegate. Next we have example of single cast delegate. Here we have the definition of delegate. Here is the delegate keyword, and here is the return type, that is void, and this we provide the delegate name, means mine delegate. We can provide any name for the delegate. This is the parameter type, string type we have here, and this is a method we have, greet method, where we have a parameter string and a return type void. So these return types and parameters should be same. These are the method signature. So these should be same with the delegate. If it is not same, or if we use a string here in delegate and while creating the method we provide integer, and we are calling that method reference to the delegate, then it will give us the compile time error. And here we initialize the delegate with that name my delegate, and then provide the name for that my delegate, means variable name, and here we provide the method name but not the parentheses, because we are not calling this method directly, we are only providing the reference of the method to that delegate, and here we call that delegate, and it will invoke that method, greet method. Now let's see this one example. Now let's see the single cast delegate. First we have to use the delegate keyword, and here is the return type, and next we have to provide some name for that particular delegate, and then it comes the parameters. Now we shall create some method, display value. Here we provide some text value, and here we can display some name through console.writeLine. Play message, text value. So this is the method and this is the definition of delegate. Next we have to initialize the delegate with the delegate name, that is my delegate, and here we provide the delegate name, and then we give the method reference here, means display value. So this is a single cast delegate and reference of method, and here we can call this or invoke this delegate. Here we can pass some message, calling display value method here. Now here is the thing, first we provide the definition of the delegate, means delegate keyword, and then return type, then delegate name with the parameters, and this is our main method. where we create a display value method, and method signature should be same, parameters plus return type. We are just displaying some message here. And in main method we initialize the my delegate with that name my delegate, and then we provide some variable name here. Here we provide that method name. We are not calling that method name here directly, and here we invoke that delegate. While invoking that delegate, it will invoke that particular method. Here we are passing that parameters, that is programmers means string value. So now let's see the result of this one. First we can use the breakpoints also here. Use the breakpoints. Now here we have the breakpoint. It starts from main method. Here we are passing the method name. Now it is not invoking that method, only we are passing the reference of that method to the delegate. Now here it will invoke that particular method, means display value. Now it is invoking that particular method. Now we have the result. Here we have the result of this one, that is programmers, that we pass through the delegate. So this is the single cast delegate. First we have to declare the definition of the delegate, and then we can create any method for doing any calculations, for displaying any message. And then in main method where we are calling that delegate, first we have to initialize that delegate, provide some variable name along with the method reference, not the method invoke. And here we can call this delegate, and here it will automatically call that particular method, that is display value. Next we have multicast delegate. So what is a multicast delegate? It can store references to multiple methods. So if we have multiple methods and we want to use that delegate, then we can approach to multicast delegate. So it is a good one if we have multiple methods. It will invoke all methods in a sequence. If we suppose put all reference methods to that multicast delegate, then it will invoke all methods in a sequence in order where we are adding those methods reference to that delegate. So why use it? It is useful for scenarios where multiple actions should happen when something occurs, like event handling. So if we want to have multiple calculations into our multiple methods, then we can use this multicast delegates, where we are providing any events handling. We have structure like that of that program, then we can go with this approach. Here we have some key points. Order of execution is the order in which methods were added. So order is of execution, as I already told you. If we add methods in a sequence, then it will invoke all the methods in a sequence, not without any sequence. If one method throws an exception, then chain stops unless handled. If any one of the method throws an exception while executing the code, then that all the chain will stop instantly, unless if we handle it properly. Next we have a multicast delegate example. Here we have the delegate definition, and we provided two methods, so we can go with the multicast delegate. Here is the symbol plus and equal to. First we have to initialize that delegate, and then we provide first method reference and then second method reference with plus or equal to. So it will add another method in a sequence, and then we invoke this delegate. It will invoke all the method in a particular sequence. Now let's see the multicast delegate. Suppose this one is our first method. Third one. Next we can create a method 2 for that. String value. Then we can put method 2 called. So these are the two methods. We have to use these two methods and call these two methods through our delegate. So here is the thing. This one is multicast delegate, and here we have to pass the reference of the method. So this one is our first method, and second method, if we want to add reference, then we can put that second method name, and then it will automatically invoke all the methods in a particular sequence. For more clarification, we can set some breakpoints, like it will invoke in a sequence or not. Now let's run this one. Here we have the breakpoint in our main method, and first we add first method reference to the delegate, and then second method reference to that particular delegate. So here our delegate have two method reference. Now it will invoke one by one. Now it is invoking our first method, which was added first in our delegate, that is method 1. Second, we have method 2. It will invoke in a second position. Now it invoked all two methods in a sequence. Here we have the result. First one is that method 1 called. So and next method called was method 2. So we have the same result. So method signature should be same in both methods. If we have multiple methods or any single method, the method signature of all methods should be same with the delegate. Suppose here we provide some other return types. Now it will giving us the compile time error, as the method signature is not matching with both of the methods. So the method signature should be same for return types and parameters in delegate and in methods. So if we want to use that delegate, we can go with void. Otherwise we can check this one also. We can change this type like this. So this method's type is now changed, and now we have to return some value, as we are returning some value through these methods. So these are multicast delegate. We can provide multiple methods for multiple calculations. If we want to use that methods through the delegate, then we can approach this multicast delegate, and we can add multiple methods like this. Next delegate we have a generic delegate. So what is a generic delegate? A generic delegate is a delegate type that has type parameters, allowing you to define a delegate that can work with any data type without creating separate delegate definitions for each type. So generic delegate is a delegate where we have type parameters. Type parameters means we do not provide any definition of that delegate. We directly use that generic delegate with the methods, where we can directly use the calculation into that particular delegate. So that is a generic delegate without creating any separate delegate. Means we do not want to create any definition separately, and then we can invoke that particular delegate. We can create that inside the main method with the proper type. They increase code reusability and type safety because the type is specified at the time of creating the delegate instance. So here we can reuse that code again and again where we want it, and it is type safe because we provide that delegate name if we are creating any delegate inside the main method. So we can directly use that particular type while we are creating any delegate instance, while we are creating any new delegate. Here we have some types of generic delegates. Func, action, predicate. So these three are the generic delegates type. We will see all one by one with example. First generic delegate we have, that is Func delegate. It takes 0 to 16 parameters and returns a value. So if we want to go with Func delegate, we can provide 0 to 16 parameters plus one parameter, that is a return type, means a total 17 parameters we can provide. Only 0 to 16 parameters means we only provide those parameters for inputting the values, means we can provide some values. And 17th parameter is, it is a must, means it is a return type. We have to return something if we want to use that Func delegate. Its last type parameter is always the return types. As I already told you, the last parameters always be the return type. Without it, it will give us an compile time error. Here we have the example, like this is a Func declaration, Func keyword, and here we have two parameters, means three parameters, but first two parameters we are providing the value, and third one is the return type, that is a string. It means integer and integer are the parameters and string is a return type. So why use it? Ideal for calculations or operations where you need a result. So if we have any particular calculations, if we want to display any data and want to return any data through that particular delegate, and then we can go with this one approach, that is Func delegate. So here is the declaration Func, and then we provide three parameters, two parameters we provide some value, and third one is the return type. Here we have the variable name for that Func delegate. Here we provide two parameters for this one, and then we give some logical operations. We perform some operations over here, and it produces a return type which will return through integer. Now we call this one with add variable name, and then we pass two parameters. Now let's see generic delegates. First we can comment this one. Now let's see the examples of generic delegates. This first one we have Func delegate. Here we can declare this Func, and then we can provide some parameter here. Three parameters we have, but first two parameters we provide some value. So these are the parameters values, and third one will be the return type. Here we can provide some variable name for this Func delegate, and then we can provide the parameters name. Here we can use the Lambda expression, and then we can do some calculations here. We can print the result in console.writeLine. Here we can call this Func delegate. It can provide some value. Now first we can see what will be the output of this one. Now here we have the value, that is 60. We provide 10 and 50. It added both values and give us 60 value. Now here is the thing in Func delegate. Here is the declaration where we provide three parameters. Two are values which we provide, and third one is the return type. We can provide 0 to 16 value, but the last parameter should be the return type. Here is the delegate name. Here we provide the parameters which we are going to use, and here we did the calculations, and then we can invoke this delegate, and it will do all the things inside that delegate. So this is a Func delegate. We can do it with another way also. Let's see this one. if we want to use this method too with our func delegate, then we can go with this like this. We can use this method name like this one, but we have to set the parameters. We have to provide here integer value and second value we have. Here we can go with the calculations part, and I do not need to print the values here. We can directly return these values. Second value, and now our func delegate is ready through the method. Here we are creating some separate method, and we are using that particular method inside that func delegate. So here we are like providing the method reference, not directly we are calling this method. We will call this method through the delegate, where we invoke this delegate with that variable name. Here we are providing the parameters. Now let's see the result. As it is giving us same value, that is 60. So this is a func delegate. We can go with this one directly without creating any method. We can do the calculations inside this func delegate with the declaration, means where we initialize this delegate, we can directly use any calculations inside this one. And second thing, we can go with the method part also. If we want to create some separate method, and then we can do the calculations inside that method, and then we can pass this method reference to that delegate, and then we can call this one through the func delegate. And but here is the thing, we have to use the same method signature, means return type plus parameter should be same of that particular method and that func delegate. Suppose here we provide string return type. Now it is giving us the error, that is method signature is not matching for this func delegate with the method name. So if we want to use this one, then we have to provide same method parameters. Here same parameters with the same return types. This is must. Next one we have action delegate. It takes 0 to 16 parameters but returns void. So it is totally opposite to that func delegate. As we can get the return value in func delegate, but in action delegate we do not get any return type, means we do not get any value in return. It always returns void. But we can use same parameters 0 to 16 in action delegate. Here is the example. Here we have declare action delegate, and these are the parameters we will pass. Here is the string and int are the parameters, but return type is void, means we cannot return anything through this delegate. So why use it? It is best when you just perform an operation without returning anything. So it is best if we do not want to return any value through this delegate, then we can approach this action delegate. Here we have the delegate, action delegate declaration, that is action, and these are the parameters, variable name for that and parameter name, and here we are printing directly through the message. Here we are calling this delegate, that is print delegate, and we are providing some parameters. Now let's see the action delegate. Delegate, first we have to use the symbol, then we can provide some value. We can provide multiple parameters 0 to 16, but we do not return any return value. Here we can use some name. Here we have to provide some value. So these are the two parameters, and here we can display those values through console.writeLine. First value we have, that is value, and then second value we have, that is message. Here we can call this action delegate through this variable name, and then we have to pass some values here. Next we can provide two string parameters through this one. Now let's see this one result. Here we have two values. First one is developers first value, and then second value, that is CSharp. We pass two parameters values. It displays two values. So this is the thing in action delegate. First we have to declare it, and we can use 0 to 16 parameters without any return type, because it always return void, means nothing it will return. Now we provide some name for this delegate, and then parameters, and then we directly display this one values, because we cannot return any value. So if we want to do any calculations and we do not want any return value, then we can go with the action delegate. And we can also use the delegate with the method name. If we want to do all calculations inside any method, then we can go with this one. Here is the thing, display text. Here we can provide some value, string value, some message. Here we can display, we can do all these things inside this method. Through the method we can use this action delegate. Now we provide the reference of that particular method, and the method signature is matching with that method plus delegate. Now let's see this one. Here we have the error. We have to provide this name. Now here we have the first value, that is developer, second value, that is CSharp. So these are the two parameters values we are getting through the method, not directly in the action delegate. So this is the thing in action delegate. First we can go with this one approach also. If we want to directly use that action delegate with the calculations part, we can do it in this way. And second, we can go with the separate method. We can create some separate method, and through that method we can use this delegate. First we have to put the reference of that method, and then we can call this delegate. So this is the action delegate. Next one we have predicate delegate. This is the third type of generic delegate. So it always takes one parameter and returns a bool. So if we want to send only one parameter, then only we can go with predicate. And also here is the thing, it only returns bool value, means true or false. Rather than this, it will not give any value, means not any integer value, not any string value. It will give us only true or false value, that is boolean value. Here is the example, that is a predicate, and we are using only one parameter, that is int, means integer, and return type is bool. So why use it? It is perfect for filtering, validation or searching logic. If we want to filter the data Okay, and if we want to use the validations, or if we want to do the searching logic into our program, then only we can go with the predicate, because it will return only true false value, means boolean value, and we only provide one parameter value for this one. Here we have the initialization of predicate delegate, that is one parameter, and that is variable name, that is parameter, and here we are doing some calculations. Now let's see the predicate. Predicate delegate. Here we can give only one parameter, then provide some name, and then provide some parameters, then use the lambda expression, then we can do some calculations if we want to do. Here we can check the number is even or odd, we can check here. Next we can call this, but it will only print us boolean value, means 1 or 0, true or false. Is even. Now we can call this delegate, and we can pass some value here. Now let's see this one result. Here we are getting the boolean value, that is true, means it only returns boolean value, true or false, as we pass two value, and it checks that value, that is even or not. So this is even number, so it will return true. Suppose if we pass some odd value, then what it will give us? Here we have false value, because 3 is not even. So here is the thing in predicate. Suppose if we want to provide some other parameters, now it is giving us the error, because it only takes one argument in predicate. If we want to use this one, it only takes one argument with one return type, that is only boolean, means true or false value it will give us. It will not directly give us that particular calculated value, it will give us true or false. We can also do in this way. We can go with this one also. Let even number, you can pass integer value, and if we are using predicate, we have to set the return type bool, and here we can do all these calculations inside this method. Now it should return some value. Now our method is ready, we have to use it in our predicate. Now let's call this method. First pass this method reference to the predicate, then it will call the method through the delegate. Now let's see what it will give us. We are getting the false value, as I think we are providing odd number. Okay, we are providing odd number, and we are getting that number is not even. And here is the thing, the method signature is also same here. First we are providing integer value, so parameter should be same, and return type should be boolean. If we change this type, it will give us same compilation error, because the method signature is not matching here. So if we want to use these methods with the delegate, we have to follow that method signature. It is must in all delegates. So these are the two ways if we want to use that predicate. Through directly we can do the calculations inside that delegate, or we can create some separate method, and inside that we can put our calculations, but we have to call this method through our delegate. First we have to pass our reference of method to the delegate, and then we can invoke this delegate, and it will directly invoke this method where we can use it. So this is our predicate delegate. Next we have delegate with anonymous method. Anonymous method, as I already told you, means without any name we can create delegate with all method calculation inside that particular delegate. Instead of writing a separate method, you can create the method inline using the delegate keyword. As I already told you, if we do not want to create any separate method for any delegate, for any particular delegate, then we can go with this one approach. We can directly initialize the delegate, and inside that delegate we can do our calculations or print any value inside that delegate. So why use it? It is useful when you need quick one-time method logic without cluttering the class with extra methods. Here is the thing: if we do not want to create any extra methods for any particular delegate, then we can follow this approach, means anonymous method, where we can declare all calculations while initializing the particular delegate, means like this. Here we have the anonymous method where we define the delegate with the delegate keyword, return type, delegate name with the parameters, and inside that main method we initialize that my delegate with variable name. And then if we do not want to create any separate method, we can go with this one approach, means anonymous approach. So here we use the delegate keyword name, and then we provide the parameters. Inside these curly brackets we can put our all logic of our all methods which we were providing into our separate method. We can directly use that calculations into this one same delegate. Here it perform all the operations inside that delegate while initializing that delegate, and here we are invoking this delegate. Now let's see the anonymous types. Delegates. Here first we have to put the definition of the delegate. We can comment these methods as these are not required for now. Here we provide some value, and if we do not want to return anything, we can do like this. Anonymous delegate, first we have to initialize this delegate, then we can provide some name, and then if we want to go with the declaration, then first we have to go with this value. Now we can do any calculation inside this, because this one is anonymous type. Without creating any separate method, we can directly put our logic into this method. So we can display any message inside this one, display value, and then we can call this delegate and pass some values here, programmers. Now this is our anonymous delegate, where we are initializing this my delegate, and while initializing we can provide any logic, any calculations inside this delegate without creating any separate methods for this one. Now we have the value that is printing programmers, as we pass the programmers through the delegate. So these are the anonymous methods. We can change the parameters also and return type also. If we want to return anything, we can go with this one, and if we want to use any integer type, we can do this also. Here we can also do some calculations. Return values u plus 100 like this one, and here we have to provide some integer value, and now we are returning some integer value, so we can get these values through the internal values. Next we have to display these, and then we can go with this way. So we are returning some integer value and we are displaying the return value through the console.write line. Here we have the calculated value, that is 150, as we are giving 50 and we are adding this value with 100, so we get 150 value. So this is anonymous delegates, and if we want to use it with the predicate, action or func delegate, then we can go with this approach also. Like anonymous delegates we can use with any type, with any delegate we can go. Suppose if we want to use it with the predicate like this, we can go with this way. Predicate, and here we can do this one. Here we can do the calculations. Here value we have, here we are returning only bool value, so we have to set this one also, as the method signature should be same, means predicate only have one parameters along with one return type should be boolean. So here is the thing in, so we are using anonymous method with the predicate. Now let's see the result of this one. So we have the result value, that is true. So now we are using predicate with anonymous method, and we are calculating all our calculations inside this predicate delegate with anonymous type. So anonymous type we can use with any kind of delegate, with a single cast delegate, multicast, func, action, predicate, any generic delegate we can use with anonymous type. So these are the anonymous types, we can use it without creating any separate method, any single method. We can do our all calculations inside this anonymous method. Next we have delegate with lambda expression, a shorthand way to write an anonymous method. If we want to use anonymous method without any delegate name, without any method name, we do not want to create any specific method, we can directly put our logic into that anonymous method, so we can use with delegate. So it is a shorthand operation with lambda expression. Suppose if we have only one line of code, then we can go with this one, as I already told you about block body and expression body. Expression body we can use with lambda expression if we have only one line of code, and if we have multiple lines of code, then we can go with block body. Like we can put our logic into curly braces. So why use it? It provides a clean, concise and preferred in LinkU and modern C# coding. And it provides a clean code, concise code and preferred in LinkU queries. We can discuss this LinkU queries into our later lectures. And it also provides modern C# coding, as if we want to use the C# modern coding, then we can go with the lambda expression. Here we provide the definition of delegate, delegate keyword with return type, with the delegate name and the delegate parameters we have. Here we are using lambda expressions. If we have only one line of code, then we can go with the lambda expression. Now let's see the lambda expression. Like here we use it with suppose in action. Here we can use action delegate. Here we are using lambda expression. Here we have only one line of code, so that's why we are using lambda expression. Otherwise we have to go with the block body approach, means we have to put our all logic into curly braces. If we have multiple lines of code, only in one line of code, then we can go with lambda expression for modern C# coding. So here we are using action delegate, means generic delegate we are using. Now let's see this one result. Here we have a first value, that is a developer, second value, that is a C#. So here is the thing in lambda expression. If we want to use this one, only we have if we have one line of code, then only we can go with this one. Otherwise we have to use the block body approach. Next we have today's summary. Now let's revise what we learned today. First one, we have a single cast delegates. Single cast delegates, it points to and invokes a single method at a time, means it only invoke one method at a time. If we have only one particular method and we want to invoke that particular method only, then only we can go with a single cast delegate. Next delegate we have multicast. It can hold references to multiple methods and invoke them in sequence. So multicast delegate performs into that situation if we have multiple methods and we want to do all our calculations inside multiple methods, then we can use multicast delegate, and it will hold all methods reference into that multicast delegate if we want to perform that, and it will invoke all the method in sequence, not without any sequence. Next one, we have a generic delegate. Here we have three types: func, action and predicate. So it is built-in delegates for common patterns. Func return values, action no return, predicate returns bool. If we want to go with generic delegate, we have three types. First one is func delegate. Func delegates we can use 0 to 16 parameters, and last parameter should be the return value. So it must have one return value inside this func delegate. And if we want to use action delegate, here we have 0 to 16 parameters, but here we have no return type. Return type is void here in action delegate. And in predicate, if we want to use only one value, means we have only one parameter value, then we can go with predicate, because it only supports one parameter with one return type. Return type should be only boolean. If we want to return any true false value, then only we can approach this predicate. Next one, we have delegate with anonymous method. It defines and assigns a method to a delegate without explicitly declaring a separate method. If we do not want to create any separate methods for any delegate, then we can go with anonymous method, where we do not provide any method name. We directly put our all logic of all methods logic into our one delegate. While we are initializing any delegate, then we can put our all logic or all calculations inside that anonymous methods. Next one, we have delegate with lambda expression. It uses a concise lambda syntax to define the method logic directly within the delegate. As I already told you, if we have only one line of code, then we can go with lambda expressions for modern C# programming. And if we have multiple lines of code, then we can use a curly braces, means block body. Inside that we can write our calculations. If we have multiple lines of code, then this approach will not work, means lambda expression. Only it will work in that scenario if we have one line of code. So these are the delegates which we studied today. You can practice all of them into your Visual Studio. If you have any doubt with any topic, you can mention them into the comment section. So let's wind up today's session. Thanks. See you in the next lecture.